How's it going, everybody out there? In this video I'm going to be talking about section 4.2. There are going to be a ton of definitions in this, so make sure that you guys take notes really well. Make note cards to help you memorize the definitions. If you don't know what the words mean, you are not going to do well. So with that being said, I'm just going to jump right into it because it's going to be a little bit lengthy, so I'll try to keep it as short as possible. So with this, degrees and radians, we'll talk about what a radian is here in a little bit. But the first thing you need to know is something called degree minute seconds. Pretty much this is used in, what is that thing called? Longitude and latitude. Whenever you see like 118 degrees, 32 minutes, and 47 seconds, right? You can look at a map and see it. So if you are a surveyor, you will have to use that. The shortcut to this is DMS. So you may see an example like so. So convert this angle to DMS. Well, all we need to do is use our calculator. I'll zoom out a little bit so you can see this. Zooming in. There we go. So I'm going to go 117.825. Just enter it exactly how I see. And I want to convert it. So under angle, there we go, angle. If you hit second angle, it will take you to this screen. And then hey, number 4 says 2DMS, so 2DMS. Hit enter and copy the answer. Literally as simple as that. And there would be your solution. Okay, so likewise we can go the other way. So say we are given, I don't know, 120 degrees, 36 minutes, and 47 seconds. We can take that and convert it to a decimal degree form. And all we have to do there is just punch it in, exactly like we see. So 120 degrees under that angle. You have your degree symbol. 36 minutes is also under angle. And then 47 seconds, so I can hit 47. On that, the second sign is right there above the plus. It's in green, so I'll hit alpha plus. And there's your second sign. Hit enter, 120.613. So 120.613. That's not a 3, that's a 0, but that's a 3. Yay. Degrees, happy. Yay! Alright, the next concept that I'm going to talk to you guys about is something that we call radians, which is just another degree measure. So this shows you here, if we have a radius r, this angle right here is considered to be 1 radian. Pretty much it's just the same length that this is right here. We know that a full circle is 2 pi radians. I don't know where it went. Here, I'll just write it out. So first full circle is 2 pi radians. Well, if I cut that in half, then I know that each half of this thing is 1 pi radian. And if I cut it into quarters, then this is pi over 2, and this is pi over 2, and pi over 2, and pi over 2. Because I cut this in half, so that's just half of pi. So pretty much what that means is as we go around a circle, if I start here and go around, then this would be 0 degrees, or 0 radians. This would be pi over 2 radians. That would be pi radians. This would be 1.5 or 3 pi over 2 radians. A full circle would then be 2 pi radians. Right? So based on the radius, this is just the angle around the circle. It's just another way of saying our angles. Just like if we had a full circle in angles, 360 degrees, if I cut that in half, then each one is 180 degrees. If I cut that into quarters, then each one is 90 degrees. So as I go around the circle there, this would be like 0 degrees, then straight up would be 90 degrees, 180 degrees, 270 degrees, and then a full circle would be 360 degrees. We will talk about this a lot more when we get into, well, actually right now. Ha! Yeah! So let's do some stuff with it. Okay, so these are your conversion ratios. If you are converting from radians to degrees, you are going to multiply by the number 180 over pi, which is basically 360 over 2 pi. It's just saying their equivalencies. The way that I remember that is whatever you want to have on top, you put on top. So this 180 represents degrees. The pi obviously represents radians. From radians to degrees, put the radians on top, so pi over 180. Same numbers, just make sure you pay attention to where you put the numbers. Let's do a few of these. All right, so if I want to convert 30 degrees to radians, I'm going to multiply by pi over 180. The easiest way to do this is probably going to be cross-reduce. I know I can divide by 10 on both of them, and 3 over 18 is 1 over 6, so this is the same thing as pi over 6. There it is in radians. Okay, this one's same thing. I'm going to multiply by pi over 180, and I can cross-reduce 10, 10, 27 over 18 would be 3 over 2. So I have negative 3 pi over 2, and there we go. Okay, now we are converting to degrees, so I'm going to multiply by 180 over pi. Well, notice that pi divided by pi is 1. 18 divided by 3 is 60 over 1, so this would just be equal to 60 degrees. Make sure you put a degree symbol, please. All right, last one of this type before we get into something new. So converting to degrees, I can multiply this by 180 over pi. That's a weird pi symbol, but pretend it's pi. 1 divided by 1, 18 over 12. I'm going to take this slow, 90 over 6. Divided in half again, 45 over 3, so 15 degrees. Oh, negative 15 degrees. Can't forget that negative outside. All right, next concept I'm going to talk to you guys about is something called coterminal angles. Don't forget that we have a kind of circle type thing, but as we go around, notice this one changing, you are going to continually add the angles. So like remember that was 270 straight down there, this was 180, I can't get it exact, maybe if I move up further, 180, this was 90, ha, and then a full circle was 360 degrees. Okay, but what coterminal angles are is if you keep going, your angles will keep adding. Coterminal angles just mean that they're angles in the same place. So once they have reached angles that reach the same position around the, we call it a unit circle, they are considered to be coterminal angles. So notice that 60 and 420 degrees are only 360 degrees apart, or a full circle. So if I add a full circle to 60 degrees, that ends up being 420. Well, likewise, if I go around the other direction, if I do 60, oh come on, technology. If I do 60 minus 360, then I end up with negative 300 degrees. So these two angles are also coterminal. You can go around as many times as you want in either direction. It really doesn't matter, and you're passing a ton of coterminal angles along the way. But this one would be a coterminal angle, 60 and negative 4,260. Okay, so let's do a little bit a few things there. So say we are trying to find some coterminal angles, one positive, one negative coterminal angle, and I am given the angle 120 degrees. Well, the way I can find a positive one is if I add a full circle to it, then this would end up being 480 degrees, and if I subtract a circle from it, minus 360, this would end up being negative 240 degrees. So there I have it, a positive angle and a negative angle that I know are in the same exact position as 120 degrees. So if you really want to, we can check that. Reset. Let's put that at 120. And then a full circle around. Hey, check that out, 480, exactly what we got. And then if I go the negative direction, hey, check that out, negative 240, exactly what we got. Okay, so again, finding coterminal angles. If it's given to you in radians, keep it in radians. So for this one, a full circle, to add it, I could add 2 pi. In order to get a common denominator, that would need to be over 4, so I'd need to change that to 8, such that 8 divided by 4 is 2. So this would be a total of 5 pi over 4 for a positive angle. And then if I subtract the 8 pi over 4, then this would end up being a negative 11 pi over 4. There are my two coterminal angles. For any given circle, we have something called a central angle. You have the arc length, which is just the outside length of the circle. You also have the radius, which you guys know what that is. To find the angle, or the arc length or the radius, we use this formula, theta equals s over r. And you can find any part. So let's just do a few of them. It's just a matter of practicing. Make sure you memorize this, theta equals s over r. Or you can also remember r theta equals s. However you want to remember that. Makes no difference. Or you could even memorize r equals s divided by theta. Okay, the only thing that's really important here is theta must be into radians. And Radians. Has to be, otherwise it will not come out correctly. All right, so say we have an example like this. I have theta, I have r, I'm trying to look for the arc length, which I know is s, so if I know theta equals s over r, then I have 2 pi over 3 equals s over 3. Well, if I multiply by 3 on both sides to get rid of that, solve for s, then I have 2 pi equals s, so my arc length is 2 pi. If you want to, you can also say that this is 6.28, whatever you want. Make sure that you say inches, because my radius is given in inches, so your arc length needs to be given in inches. All right, looking at this one now, this is one you would have a calculator for. So I have theta equals s over r. Notice this is in degrees though. I need to convert it to radians by multiplying by pi over 180. So in doing that, I come out with 7 pi over 12. Now I can use that angle and say theta equals s over r, so s over 18.2. 18.2 times 7 pi over 12 times 18.2. So s is 33.35. I don't care. Yay, and I'm in centimeters, so I will say centimeters. Happy day. Okay, next thing we are going to talk about is angular speed. This is your angular speed right there. It is based on your angle over time, or your angle with respect to time. Biggest thing here is just make sure that your units line up with each other. If you have different units, you need to use dimensional analysis, which you learned in chemistry, which we'll also go over a little bit here of how to do that to make sure your units match up with the rest of the problem. So I'm just going to jump right into this and get an example going with you guys. All right, so with this problem, take a second, make sure you write it down while we have clicky-clack in the hallway. Yep, spirit water. Got to put that ammonia on your head, bean kids. So with this, notice it says it wants to find it in revolutions per minute. Well, I know that 1 revolution is equal to 2 pi radians. And per minute, I know that there are 60 seconds in 1 minute. So using dimensional analysis, 2 pi radians per 1 second. Well, again, I said that there are 2 pi radians in 1 revolution. And notice that will get rid of the radians, so then we are in revolutions. And there are 60 seconds in 1 minute. 1 minute. So that gets rid of my seconds unit. And then it's just a matter of simplifying and multiplying. So 2 pi divided by 2 pi makes 1. So really I just have 60 revolutions per minute. Revolutions per minute. And that's all we need to do in that one. All right, check this one out. I like this one because we have to think a lot in this one. So it's an awesome problem. With this, velocity means how fast the thing is going. So say we have a ball and it is rolling 144.2 feet per minute, and it is revolving, so going around in a circle, and it is making 10.9 revolutions per minute. So if I know that I am revolving at 10.9 revolutions per minute, I have 10.9 revolutions in 1 minute, and it is going 144.2 feet in a minute. So for 1 rotation, I can do 144.2 divided by 10.9 to figure out 144.2 divided by 10.9 to figure out that in 1 rotation it travels 13.23 feet in 1 rotation. 1 rotation. So it just spins around 1 time, makes 1 complete circle, and it goes 13.23 feet. So to figure out the radius given that, well, I know that this is along the outside of the circle because that's how, circles travel. They don't go on the inside to move against the ground. Think about tires. They hit the outside of the circle, so the total distance that it travels is this part, then this part, then this part, then this part, then this part, until it makes the full revolution around that circle. Okay, so if I take this, and I know that this is circumference is equal to pi times the diameter, well, this is my circumference. I have pi. Pi is just the constant 3.141715, right? Oh, whoops, I messed that up. 3.1415932, I don't know, something like that. So I have 13.23 equals pi times the diameter. So I can figure out that 13.23 divided by pi is equal to 4.211. So diameter is 4.211. If I know that the radius is half of the diameter, just divide that number by 2, and you will get that the radius is 2.106 feet. Yay. Okay, next thing we're going to talk about is area of a sector of a circle. Don't forget that your regular area formula is pi r squared. So that's of a full circle. Well, you know in a full circle that the angle is 2 pi, but say we just have a part of a circle, a sector of a circle, and I don't know what the angle is. Angle. Well, if this angle was 2 pi and it came out as pi r squared, well, it looks like I just took that and multiplied that by 1/2, and then it came out as my area formula. Well, hey-oh, that's all really it is. So area is equal to 1/2 theta r squared, where again, make sure you are in radians. Anytime you are using theta in a formula, it needs to be in radians so that we do not have to do any more converting with it. It just makes making math easier. So let's take a look at an example. All right, in this problem, I'm finding the area of the sector of a circle. So I know I have a equals 1/2 theta r squared. I have the angle, but right now it's in degrees, so I need to take 140 and multiply it by pi over 180. Well, that will reduce. 14 over 18 is 7 over 9. So 7 pi over 9. So I have 1/2 7 pi over 9. And the radius is 10.2 squared. So then it's just a matter of punching that in your calculator, like thusly. Okay, so we have 127.109. So 127.109 kilometers squared, since we were talking about the area of a, well, we're talking about the area. That's all we really need to know. All right, next thing I'm going to talk to you guys about is supplementary and complementary angles. So you can see it right there. I just highlighted. Yeah, it's at the top of my paper. Supplementary angles add up to 180 degrees. Complementary angles add up to 90 degrees. Notice that in both of these examples, these are both positive angles. If you find any angle that is not positive, it is not a complement or supplement angle, or it has no complement or no supplement angle. Both angles have to be positive. Both angles add up to 90 if they are complements. They add up to 180 if they are supplements. This is a little helpful thing they had. They said the 8 kind of looks like an S, so supplements add up to 180, complements add up to 90. Notice this is also pi, this is pi, and this is pi over 2. So if you have it in radians, you can do it that way as well. They just do more examples. Yay! All right, last example of the video. Find the complement and supplement angles to 6 pi over 7. Well, I know for the complement angles, it is some angle plus 6 pi over 7 is supposed to equal 90 degrees, or pi over 2. So if I subtract that 6 pi over 7 over to the other side, minus 6 pi over 7, I need to have common denominators, so I can multiply by 7 over 14. 7 over 14 is 1/2. And this would be 12 over 14. So this would come out as negative 5 pi over 14. Since that is a negative angle, it does not work, so there would be no complement angle. For your supplement angles, I know I have some angle plus 6 pi over 7 equals pi. Well, 1/7 plus 6/7 is equal to pi, so 1 pi over 7 plus 6 pi over 7 is equal to pi. Yay! Hopefully this helps you guys out. I love you guys. I will see you in class. Take notes, make flashcards. Yeah, I'll stop jabbering. Bye-bye!